All right, this is Module 1, the end of module review. We're going to go through this, and this is what you should know for that test that you will be taking tomorrow in class. So for the following pictures, determine if the drawing is an enlargement or a reduction. Just remember that an enlargement is bigger, reduction is smaller. So here's the drawing. Here's the actual horse, so that would be considered a reduction. All right, section 2 is all about finding scale factors. And I'm just going to remind you that we learned in class that a scale has two numbers. A scale factor has just one number. It's your unit rate. So let's go through and read number 2. It says, Emma made a scale drawing of a swimming pool. The pool is 8 millimeters long in the drawing. The actual is 48 meters long. First, it says, what scale did Emma use? Now, the scale, excuse me. We don't have to do this. Don't change that until the second part. But anyways, the scale comes from the drawing value, and we're going to set that equal to what the actual value is. So let's read it. It says 8 millimeters. That would be in your drawing. The actual pool is 48 meters. So we can't start with the 8. We got to divide both sides by 8. So 1 millimeter is equal to 6 meters. That is your scale. Two numbers that are comparing the drawing to the actual. Part B says, what is the scale factor? Now, this is where the hint comes in, where you're changing meters to millimeters. So I'm going to remind you that scale factor is a unit rate. So to find unit rates, we're going to do K equals Y over X. We're going to do drawing over actual. So you're going to take your numbers from the scale. So your drawing number in the scale is the millimeters. The actual in the scale is the meters. Now we have to change them so they're the same units. These are metric systems. So I'm going to do King Henry doesn't usually drink chocolate milk. And we want to go from meters, which is your units, all the way to millimeters, which is your M. So that goes 1, 2, 3 units to the right. So 6, the decimal place starts at the end. 1, 2, 3 units to the right would be 6,000. So 1 millimeter is really 6,000 millimeters. Now your units are the same, so they cancel out, and you're left with 1 over 6,000. This right here is your unit rate, your scale factor. This is your scale. This is your scale factor. All right. Next page, number 3, we're going to practice the same exact thing. So Clara made a scale drawing of a shopping center. Bakery at the shopping center is 35 inches long. The actual bakery is 70 feet long. So part A, what scale did they use? So we're comparing the drawing value, which is 35 inches, to the actual value, which is 70 feet long. Now you don't want to leave it like that. We're going to divide both by 35. So 1 inch, if you divide that, you get 2 feet. This is your scale. 2 numbers comparing drawing to actual. Now part B is asking for the scale factor. So scale factor is unit rate, K equals Y over X. Your drawing goes on top. Your actual value goes on the bottom. And you take it right from the scale. So 1 inch is equal to 2 feet or over 2 feet. Now we have to make them both the same units. So let's change 2 feet to 24 inches. So inches cancel out, and you're left with 1 over 24. That's your scale factor. All right, number 4 is also a question talking about what is the scale factor from rectangle ABC to EFGH. So we're going to do K equals Y over X. That's your unit rate. We're going to compare the drawing values to the actual values. Now, in this picture, this is your actual picture, and this is your drawing. And when you take the values, you only need 2 of them. You need to take the pieces that are corresponding, meaning they lie in the same spot. So what do we know about rectangles? Well, if this side is 10 right here, we also know that this side is 10. If this is 6, we also know that this is 6, and we can do that on the big one as well. So if I take the top value, then you need to take the top value on the second triangle. Or I'm sorry, these are rectangles. So from the drawing, I circled 25 inches. The actual is 10 inches. They already are in the same units, so we can cancel those out. 25 over 10, if I actually divide that, I get 2.5, which is choice B. All right, let's go to the next page. Okay, we're going to find actual lengths now. So Rita made a scale drawing of a campsite. Here's the scale that she used. What is the actual width of the tent? Or the actual width of the tent is 6 feet. How wide is it in the drawing? So the two units we're comparing are inches and feet. So that goes in our little box. That tells us inches go on top, feet go on the bottom. The first one comes from our scale. So 1 over 3 equals, now 6 feet. That goes on the bottom because feet are on the bottom, and we don't know how many inches. That's x. So we're going to cross multiply. 3 times x is 3x. 1 times 6 is 6. To solve, we're going to divide both sides by 3, so x is equal to 2. And we're talking about in the drawing, so that's 2 inches. All right, number 6. She had a scale drawing. Here's her scale, and it's 21 inches wide. So what is the width in the picnic area? So the units we're working with are inches and yards. Go ahead and make your label. The scale is our first fraction, so 1 inch is 3 yards. The other number we have is 21 inches. That goes on top. X goes on the bottom. So cross multiply. 1 times x is x. 3 times 21 is 63. That's on the bottom, so that's talking about yards. So the actual width would be 63 yards. All right, number 7, measuring a city and made a scale drawing. Here's the units, or the scale, I should say. 1 inch is equal to 2 yards. We know the neighborhood park is 138 yards, so what is it in the drawing? So we're comparing inches to yards. Make your label. The first fraction comes from the scale, so 1 over 2. This is 138 yards, so that goes on the bottom. X goes on top. So 2 times x is 2x. 1 times 138 is 138. To solve, we're going to divide both sides by 2. So I'm going to take my calculator. 138 divided by 2 gives us 69, and that would be inches because it's on the map. All right, next page. Okay, number 8, it says farmers often plant crops in circular areas because one of the most efficient watering systems for crops provides water in a circular area. Passengers in airplanes often notice that the distinct circular patterns as they fly over land used for farming. A photographer takes an aerial photo of a field on which a circular crop area has been planted. He prints the photo out and notes that 2 centimeters, here we go, 2 centimeters of length correspond to 100 meters. So that's our scale. Let's write that down. 2 centimeters is equal to 100 meters. Now we want to simplify that by dividing both sides by 2. So 1 centimeter is 50 meters. That's our scale. So question A says, what is the scale factor of the actual farm? Scale factor is unit rate, so we're going to do K equals Y over X. So that's our drawing over our actual. So 1 centimeter is our drawing. 50 meters is your actual. Now we have to convert because they have to be the same units. They're metric, so I'm going to use King Henry doesn't usually drink chocolate milk. I'm going from meters, not D. Meters to centimeters, which is 2 spots to the right. So I'm going to move it 2 spots to the right. So 1 centimeter is 5,000 centimeters. Units are the same, cancel them out, And my scale factor is 1 over 5,000. All right, part B says if the dimensions of the entire photo are 25 by 20, what are the actual dimensions? So now we have to take our units that we're comparing, so centimeters over meters, that's our label. And we're going to use the scale that we came up with above. So 1 centimeter was 50 meters. I know this is one of the dimensions. So we have 2 dimensions. We have to do this twice. 25 is the number of centimeters. That goes on top. X goes on the bottom. So when I cross multiply, I have X equals 50 times 25 is 1,250, and that's meters. Now, that was only one of them. We have to do it again. We're going to use the same scale. This time our units are 20 centimeters, and I want to know what the actual dimension is. So 1 times X is X. 50 times 20, if you could see that, is 1,000 meters. All right, so there's one more question, and it's actually not in my packet, so let me go grab a new packet, and hold on one second. I'll be right back. Okay, I'm back. Last question, number 9. Okay, over the break, your uncle and aunt ask you to help them with the cement foundation of their newly purchased land and give you a top view blueprint. A small legend says that 4 inches is 52 feet. So that's our scale. 4 inches is equal to 52 feet. Now I want to divide both sides by 4 because the scale should start with 1. So if you take your calculator, 52 divided by 4 is 13 feet. Okay, so here's our scale. Question part A says, what is the scale factor? Scale factor is a unit rate, so K equals Y over X. We have drawing over actual. We're going to use our scale. So 1 inch is the drawing. 13 feet is the actual. I'm going to change that to inches. So 1 inch stays. 13 times 12 is 156 inches. They're the same units, so cancel them out, and you're left with 1 over 156. That's your scale factor. Now, part B says, let's find the actual dimensions if the blueprint is 11 by 13. So 2 numbers, 2 different proportions. Now, we're comparing inches to feet, so that's going to be our label. 1 inch is 13 feet. So 11 inches is how many feet? So when I cross multiply, 1 times X is X. 11 times 13 is 143. And that's feet. That's one of your dimensions. Now we have to do it again for the other one. So 1 over 13 is still our scale. This time our other dimension is 13. So 1 times X is X. 13 times 13 gives us 169. And those are the 2 dimensions of the actual blueprint, or the actual foundation. All right, so go ahead and study that for tonight, and we will go, actually, you're going to be taking a test on that tomorrow. Good luck studying.